So in this video we'll be going through how to solve equations where you've got x's on both sides or double-sided equations. So solving equations where you've got x's on both sides or double-sided equations. So this is when you have x's on both sides. So to solve these equations you must first remove anything that resembles a fraction first. Now although this tends to only won't appear when you're first starting out to learn this topic, but it might appear on more extensive questions or high level questions. So if you do end up with a fraction or form of brackets, which we'll look at in some of the examples, what you want to do is get rid of them first. So get rid of anything that looks complicated. So in this particular examples topic, we've got x on both sides, so we get rid of that to make it simpler because we only like x on one side. So if you do end up with some fractions on either side, then like you can see in #1 and #2, then what you need to do is basically multiply every term or everything that's not part of the fraction by the denominator. So if we look at #1, we can see here that our denominator is 3. So I'm going to multiply everything that's not part of that fraction by 3. So I'm going to multiply the plus 3 by 3, the 4x by 3, and the minus 2x by 3. So what I end up with is 2x plus, and then 3 times 3, which is 9, equals 4x times 3, which is 12x, minus 2 times 3, which is 6. Now when we move on to #2, which just to make things a little bit easier, let me just swap that 3 for 4 so we've got different numbers. So here what we've got is I'm going to multiply everything that's not part of the fraction by the denominator, which in this case is 4. So what #2 would look like is 2x minus 5, and then it's going to be 5x times 4, which is 20x, plus 12 times 4, which is 48. And as you can see there, now what we've got are double-sided equations that don't involve fractions. So how do we go about solving equations when we have got x's or whatever letter on both sides? And it's one simple rule, is always subtract the smallest x from both sides. And if you remember that rule, it's going to be absolutely fine. Now there might be certain obstacles that you might conflict with that statement, but as I said, with regards to the examples that I've chosen, hopefully that will kind of give you an instruction of what to do when things don't appear as straightforward. So let's go straight into an example. So for this, what we've got, and I'm going to start by writing out the question again. I don't know why, but it's usually something that I always do. I think it's because I don't want to really graffiti over the actual question. So here, as you can see, we've got 3x and we've got 2x on both sides. So my choices are 3x and 2x. So I've got to ask myself which is the smallest out of the two amounts. So that's going to be 2x. So what I'm going to do is I'm going to subtract 2x from both sides. So 3x take away 2x is just 1x or just single x. The minus 4 stays the same because I'm only taking away x's, I'm not taking away numbers. 2x take away 2x is nothing. So all I'm left with is 10, or positive 10 if you want to do that. So now what we've come is to a very simple equation where we've just got x on one side. So again, I want to try and get x by itself. So let's get rid of the minus 4. How do we get rid of minus 4? We do that by adding 4. So what I've got left then is x equals 10 plus 4, which is 14. And there is my final answer. We'll move on to our second equation. So we've got 4x minus 12 equals 7x minus 10. So here I've got a choice of 4x and 7x. Well, 4x is the smallest, so I'm going to take 4x away from both sides. Now, with regards to this example, don't always assume that your smallest x is going to be on your left-hand side. It is possible that your smallest x might appear on the right-hand side or the left-hand side, so you've just got to deal with it. So here 4x take away 4x is nothing, so I'm just left with minus 12. And again, don't forget that minus, because that minus belongs to the 12, not the 4x. 7x take away 4x is 3x minus 10. And then I'm going to get rid of this minus 10 by adding 10. So here I've got minus 12 plus 10 is minus 2 equals 3x. And then I'm going to get rid of the 3, and the 3 is multiplying with x, so the opposite of that is to divide by 3. So all I've left with is minus 2 over 3 equals x. And again, you might feel it more comfortable of starting your answer with x. So you could have either of those two, but there is your final answer. Now, some of you might be thinking of, well, 3 doesn't go into 2, so let's just reach out for the calculator. And if you reach out for your calculator, depending on how new or modern the calculator, it might give you as a fraction, or it might give you an answer of 0.66666666667. Now, generally as a rule of thumb, when you're solving equations, if your answer, let's hopefully, excuse me a bit, so if your answer is not a whole number, leave it as a fraction. Now, again, you might be tempted that obviously with regards to this is a recurring decimal, so you think, right, okay, fraction is definitely the best way. If you end up with a terminating fraction, you might think, well, yeah, let's do that. But under no circumstances should you ever round your answer up. So the key thing with regards to this is never round your answer unless instructed, which is really, really important. That's why, to play it safe, always leave your answer as a fraction, if it's not a whole number, that is. If you've got like 10 over 5, don't leave it as 10 over 5, you should be able to work that out. But like I said, if it's not a nice number, leave it as a fraction. You will find that higher level questions won't necessarily be whole numbers. It tends to be low level questions that do end up being whole numbers, but again, doesn't mean that it's not going to appear on a harder paper. So the next type of example we've got is negative x's, and that's one thing that you should be able to spot in this question. So here what we've got is 10 minus 2x equals 8x plus 7. So again, if I write down the question again, so here we've got minus 2x and 8. So obviously minus 2 is the smaller number out of the two, so we need to subtract from both. Now the key thing with this is if you minus 2x, then that becomes plus 2x. Now, generally speaking, although earlier in the presentation I said for you to always subtract the smallest x, which in theory is true, technically what you want to do is get rid of the smallest amount of x. So here our smallest amount of x is minus 2x. How do I get rid of that? I do that by adding 2x to both sides. So we are technically still subtracting, but 2 minuses make a positive, so that's what we need to remember. So looking at the left-hand side, we've got 10, and then minus 2x plus 2x is 0, so it just leaves us that. 8x plus 2 is 10x, and we've got the plus 7. So again, I want to get rid of the plus 7 by minus 7. So I've got 3 equals 10x, then get rid of the 10 by dividing by 10, and so we get 3 over 10 equals x, and there is our final answer. Or you could write it as x equals 3 over 10, which is absolutely fine as well. And again, leave it as a fraction. If you reach for your calculator, you might be tempted to leave it to write your answer as 0.333 or 0.3 recurring. Would you lose marks if you wrote this? No, because that technically is correct. But again, don't be a hero, just keep it simple. If your answer is not a whole number, leave it as a fraction. Moving on to example 4. So in this particular example here, we've got two sets of negative numbers. So again, we've got 3 minus 8x equals minus 5 minus 10x. And again, although we're doing the same thing, this question is a little bit harder because of the amount of negatives that we have got in this particular question. So if we first highlight the x's first. So I've got to decide which is the smallest, minus 8x or minus 10x. Now, without thinking, you might be thinking, oh, 8 is smaller, so let's get rid of that first. When actually, minus 10 is smaller because there are negatives involved. So here what we need to do is get rid of the minus 10x. And how do we get rid of minus 10x? We do that by adding 10x. And again, just to prove that I'm not telling fibs, if we subtract minus 10x, then that becomes positive 10x. So in theory, we are still subtracting the smallest amount of x from both sides. So what we end up with here is 3 plus 2x equals minus 5. Again, when people look at this, they think, this is too difficult. Well, actually, all we need to do is swap the two things around. So we've got 2x plus 3 equals minus 5. It's not necessary, but if it's something that's going to make it easier for you to get the right answer, then that's absolutely fine. Next thing we then need to do is get rid of the plus 3, so we do that by subtracting 3. So I've got 2x equals, and it's going to be minus 5 minus 3, which is minus 8. And then we divide by 2, which gives us our answer of x equals minus 4. Moving on to example 5. So here what we've got is we've got brackets now. So again, all we need to do is, if brackets seem to be an obstacle, let's get rid of the brackets. So first thing we need to do is expand out the brackets. So again, using loops, we've got 7 times 2x, which is 14x. 7 times minus 4 is minus 28. And then we've got 2 times x, which is 2x, minus 2 times minus 5, which is minus 10. So again, just doing one simple thing of expanding the brackets out, and that would actually get you your first mark in this question. So the first thing we then want to do, the next thing we want to do rather, is subtract the smallest amount of x. So we're going to take away 2x from both sides. So I'm left with 12x minus 28 equals minus 10. And then going to get the number of, try and get x on the one side, so by eliminating the numbers. So the opposite of minus 28 is to plus 28, so end up with 12x equals 18. I'm then going to divide both sides by 12 to get rid of the multiplier of x. So I've got x equals 18 over 12, which simplifies to be 9 over 6, which simplifies further to be 3 over 2. So again, if you want to write your answer a little bit neater, there is your final answer. So moving on to question 6. So this is where we now introduce the fraction again. So if you end up with a fraction, what you want to do is, to get rid of the fraction, is we multiply everything that's not part of the fraction by the denominator. So in this case, we're going to multiply the 4x and the minus 8 by 3 first. So what I end up with is x plus 4 equals 3 times 4x is 12x, and 3 times 8 is 24. So again, we want to eliminate the smallest amount of x, which in this case is just the single x. So I end up with is 4 equals 11x minus 24. Then get rid of the 24 by adding 24. So I've got 28 equals 11x. And then we want to get rid of the 11. And just get rid of that 9, because I don't know why. I know why I wrote it, but it's just in case not necessary at this point. So what I end up with is 28 over 11 equals x, which doesn't simplify, so there we go. So moving on to example 7. So again, here we've got a single fraction. So for this, all we need to do is, we'll keep with the purple, is we're now going to multiply everything that's not part of the fraction by 3. So everything that's not part of the fraction is the plus 5, the 5x, and the minus 4. So what this then looks like is x plus, and 3 times 5, which is 15, equals 15x minus 12. Again, single x again, that's the smallest, so we take that away from both sides. So we've got 15 equals 14x minus 12. We then get rid of the 12 by adding 12. So we've got 27 over 14 equals x. And I've jumped a step, but there you go, we've got that. So the next step should look like 27 equals 14x, and there is our final answer. Now again, if you want to write this as a sort of mixed number, then that's absolutely fine. It's entirely up to you. So here what we'd end up with is 1 and 13 over 14 if you end up with an improper fraction. But again, more often than not, it's not really necessary. You can just leave your answer as 27 over 14. But again, very good practice if you can work on your mixed number conversion. Moving on to question 8. So this is where we start moving on to applied questions, where we start working on to more worded questions. So here what we've got, what it says is that a number multiplied by 2 and added 10 is 2 times the size of the number multiplied by 3 subtract 6. What is the number? Now, with these types of questions, the wording is the one thing that catches a lot of people out. So the first thing we want to do is convert the words into algebra. So if I just just kind of translate these two things into algebra, so a number multiplied by 2, so if we call the number x, it's going to be 2x plus 10 equals, and then 3x minus 6. Now, this 2 times part is the key thing. So if we call this first equation hashtag 1 and this side hashtag 2, then what this question says is that hashtag 1 is twice the size of hashtag 1, hashtag 2 rather. So in order for these equations to balance, hence the equal sign, I'm going to need 2 lots of hashtag 2 because hashtag 1 is twice the size. It seems a bit confusing, but hopefully that does make a little bit of sense. So this actually would get you 1 mark for simply translating the question into algebra. And once we've got this, as we've got a bracket, we want to get rid of the bracket, so let's just expand that out. So end up with 6x minus 12. And then we want to get rid of the smallest x, so get rid of minus 2x. So here I end up with 10 equals 4x minus 12. Get rid of the minus 12 by adding 12. So I've got 22 equals 4x. And then divide by 4. So I end up with 22 over 4 equals x, which equals 11 over 2. And there is your final answer. Now if you want to write your answer as 5.5, that's fine, because it is a terminating decimal. But again, leave it as a fraction. I'm not going to lose any marks for doing so. Now, a final example, which I'm sure you'll be glad to know, is this question. So in this question, I kind of forgot to put a couple of things just to make it a little bit more correct, which was the units. So the question here that we're working with, it says find the perimeter of the rectangle. Now, typically speaking, we don't have any numbers for the lengths, the actual lengths of each of these sides, because obviously the lengths are in algebra apart from the height of the rectangle. So one thing we do know, as it is a rectangle, is that the 2 lengths must equal the same. So what we've got is we've got 4x plus 5 equals 10 minus x. So from this, what we then need to do is find out what x is first. So again, with this double-sided equation, what we need to do is not do that. So we decide which is the smallest amount of x, 4x or minus 1x. So in this case, it's minus x. So to get rid of that, I'm going to add an x to both sides. So here I end up with 5x plus 5 equals 10. I'm going to get rid of the plus 5 by taking away 5. So I've got 5x equals 5. And then divide by 5 leaves me with x equals 1. Now you might be thinking to yourself, I've answered the question because I've done all the algebra. There you go. But wrong, because the question's asked us to find the perimeter of the side of the rectangle. So what we now need to do is now substitute x equals 1 into the dimensions. Now if this is correct, that both these sides should be correct. So here what I'm going to do is I'm going to do 4 times 1 plus 5. 4 times 1 is 4, plus 5 is 9 centimetres. Or you could do it on this one, which is 10 take away 1, which is 9 centimetres. So now what I've got, the height on this side is 4. So to work out the perimeter, all I need to do is add up each of these 4 sides. So the perimeter is going to equal 4 plus 9 plus 4 plus 9, which is going to equal 26 centimetres, and there is your final answer. So hopefully that gives you a bit of understanding on how we work out with equations with x's on both sides, and also how we can translate these into more sort of applied questions or worded questions, and also links into other areas of mathematics.